So the next thing on our agenda is loadings. So please can you hear me very well? Please indicate if
Yes,
you can see my
I
screen.
can hear you,
Thank
Engineer
you very
Casey. I can
much.
hear you. And also, I want to please notify them that we've dropped the attendance and we've rectified the issue. We've dropped the attendance in the chat box. Now they can now see the attendance.
Okay, okay. Thank you very much, Engineer Ayo. So please, the attendance is in the chat box. It will be dropped very soon. So I've please you have the I believe you have the access to the link. You have access to the link. Please help drop that in the chat box. Let me see if I can just do that right away. So Engineer Ayo, please help us with the link. So we are back and we are up and running again in our ProtaStructure. Okay, I'll drop the link. I'll drop the link. Right. Okay, yeah, it has been dropped. Okay, so we are back and we are up and running again. So here we are going to continue with our modeling. The next step in our design of this structure is now creating our loads, defining our loads, and now loading the building. As you can see, we have done with the slab, beams, walls. So loadings, beam loads and wall loads. So basically, we may not be having the time to discuss about all the loads that are here in ProtaStructure, how to define them and how to go about all of them. So, but one thing that is very important that we need to treat is our beam loads. That is wall loads on beams. Your wall loads and beams. That's exactly what we are going to discuss in the loading aspects of this training. Okay, please, Engineer Henry, please drop the attendance form again. Many people are complaining that they can't see that. So maybe if you drop it again, people that have just joined can be able to see that. Okay, so that is that. So here we have our the next thing we are going to treat is our loadings. So simply go to your loading tab. You can see here we have our loading tab over here. Simply go to that place. Now, what we are going to do first of all, we are going to define the wall, the type of wall, the different properties of that wall. Then we can now um, start applying that wall to different beams that we have here. So to do that, what we can simply do is to go to our modeling tab, our loading tab. Here we are going to find partition wall loads. Just click on it, and here we are going to get this wall loads library um, dialog. So the beam wall loads library dialog. So you are going to notice that we already have different walls. Here we have the Singapore 100, 300 millimeter external walls and all that. So these are basically walls that have been created by other users, and they are and the properties that we have here are simply based on feedback that was gotten from users across countries all over the world. So that is that. So we are going to create our um, own wall. We are going to create our own wall. So simply click on this plus icon. We are going to get this new wall that's here. That is here. So you have the option to rename that. So let's rename that. Let's say 225 millimeters um walls, just like we use in Nigeria. So you can change the option if you want. So let's say maroon, or let's get a blue color. So I actually prefer to go with the blue color. So it's just a color, it doesn't affect your design or anything like that. So here you have blue. So now here is the place we are going to now start adding the materials that make up that wall. So we have your block, and then we have your plasters. So the we have different layers in the block, in the walls. We have the actual brick block walls, or brick or block walls. Then we now have your plasters. So simply go here and say edit materials to now create this material. So you already have the desk block with the unit weight 20 kilonewton per meter square. So I'm not going to use this because the unit weight of wall that we unit weight of blocks that we now use in our country usually 24 kilonewton per meter square, but you have here 20 kilonewton. So we are going to create a new wall. So to do that, click on this plus icon that says add new load. So click on that, enter the material name. So let's just say block walls, blocks, or let's say 225 blocks. And let's now impute the unit weight of that wall. Say 24 kilonewton per meter square, and click anywhere to have that just like so. Now add another load. So let's say plaster and finishes. Let's set the unit weight to, let's say, 20, but you have the option to set the correct unit weight if you want. In my case, I choose to use 20 kilonewton per meter square. Now say okay. So now let's start adding these materials that you have now created to this particular 225 wall. Now to do that, come to this plus icon over here that says add new layer. So click on that once, and then you're going to get this select material stuff. Click on it, and then say select our 225 blocks. You can see that right there. Select that once. So let's expand this. The layer thickness is going to be 225 millimeters. This is where we put the layer thickness, and then click anywhere, and then the loading value is going to be automatically calculated. So the loading value is gotten from product of the unit weight and the layer thickness. So when you multiply this 24 by 225 millimeters, so this is in millimeters and this is in um kilonewton per meter. So when you convert this to meters and then multiply it by 24, you're going to get this value that says 5.4 kilonewton per meter square. Here is the loading value. So additionally, let's add our plaster material. So plaster and finishes, click the drop down arrow and then select that. Okay, if my screen is not showing, it's probably from your end, so try to correct that. Thank you. So here we have the option to input um thickness of that plaster. So it's 25 millimeters on one side and 25 millimeter on the other side, so which is 50 millimeters. And then when we click elsewhere, we are going to get the loading value that says 1.0 kilonewton per meter square. So you are going to notice at the bottom part of your screen the total loading value of that wall, which says total loading value, which is 6.4 kilonewton per meter square. So that is the total loading value of this one. Simply click on OK. We have now successfully created a wall load, but we have not added it yet to our model yet. So to add a wall load to our beams, so what we need to do is select that beam. Let's start from this beam, select that, left click, then right click, and then say edit load. You're going to see this option that says edit load. Or alternatively, you can select the beam and go to your beam tab. You're going to find the edit load option as well. So click on that, and you are going to get the loading editor dialog. Wait for it for like 10 seconds or thereabouts. So let's wait for the software to show that. Yeah. So here these are the different loadings that actually exist on this beam. So we have the points load, we also have thermal load, but it's not active for now. So we have points load, we have uniform load, we have partial uniform load, we have trapezoidal loads, and we have wall loads, we have partial wall loads. What we want to add is our wall load. So simply click on that icon that says here wall load. Click on it once, and we are going to get this interface here. Is going to change in accordance with our wall load. So we have the option to insert the total unit weight of our wall, but we don't have to do that because the wall load library is set to user defined. So simply click on that drop down arrow and then select that wall that we have now created, So that wall, remember the name is 2 to 5 millimeter walls. So just click on it once, and then when you click on it once, automatically the wall unit weight is going to appear here, and the height of that wall, we have the option to change that here. So let's say 2,700 millimeters, or in our case let's just say 3,000 millimeters. I mean 3,000 millimeters, yes, that is 3 meters. So that is all you need to do set about that. Now when you have now finished entering the properties of the wall that's going to be added to the beam, so you have the preview of that beam here. So simply click on that beam. When you hover around that beam, you're going to get this grayed rectangular um, um, portion. Just click on the beam to have that, and the moment you click on that, you're going to get a FBD here. That is your free body diagram showing the loading on that wall. So you have the option to pan that if you want. So right click, just the way you um just the way you shift your 3D views is response the same way like that. So now click OK. When you have now finished adding your wall load, make sure you click the OK, because if you don't click it, it will not be successfully added. So now click OK and then wait for it. So now you can see that this wall has now the color of this beam rather has now changed to the orange color, which means that it's now carrying a wall load. So alternatively, you can go to the 3D view to see that. So in the 3D view, we have this right here. So you can see that this beam here now have this wall load. So now let's do the same for other beams. So to do the same for other beams, simply click on the next beam, right click, say edit loads. Let's repeat the same process again. Now go to your wall loads. Now make sure you change the wall loads library to your 2 to 5 millimeter walls. Now make sure it's 3,000. Make sure you clicked on the beam and you have this stuff, this pink free body diagram as well, and then say OK. Now we are going to have this. So continue doing that for the rest of your beams. Right click again. So if you don't get it, let's do that again. Wall loads, make sure you have this, it's already there. Now click on this and then say OK. So you are going to have that there um as well. So go to your 3D view. We have now successfully created our wall loads, our walls on the three beams. So we are going to do the same thing for the rest of the beam. So doing this, repeating this particular process, it can be tedious. It's actually a very tedious thing to do. So there is a way that you can actually go around that, and that is copying this particular wall load. Just copy it and paste it to the rest of the beams in the model. So to do that, simply click on the beam that already has a wall load. When you click on that beam, you have the option that says copy load on your beam style. You can click that, or alternatively you can just right click and then look for the option that says copy loads. Control C, that is that, which is this copy load. Click on it once and you have the option to choose which load you are copying. So you have point load, area load, line loads and all that. So just choose your wall load and then say OK. You have now successfully copied that. So now select the beams in which you want these walls to be placed. Select this beam, hold down on your control key to select multiple beams, just like so. Now right click and then say paste loads. When you have now pasted the load, you are going to have this just like this. So go to your 3D view, look at the load that you have now successfully pasted in this region. So let's go to our plan view. So now let's now automatically select all these beams at once. So to do that, to select all of these beams, what we can do is go to our structure tree at the left hand side of your screen where we have your structure tree. Open up the story one folder and then open up the beams folder. Now select all the beams here. Simply select the first beam, then hold down on your shift key and scroll down and then select the last beam so that you can automatically select all of the beams at once. You can see that it's now selected in our 3D model. Now right click. I've already copied the loads. Right click and say paste loads. Just right click and say paste load. When you do that, you are going to have your wall loads now successfully pasted in all the beams in the model. Can you see that it's looking very good now? So this is a very fast way to copy and paste your load instead of creating your loads one after the other. So now one other function that we should have talked about is our um slab opening. You can see that we treated slab creation, properties, slab types, and we left slab opening. So let's do that. So in your model, usually there are regions where you are expected to have slab openings. That is for your stair, that is where your staircase is going to be placed. So it's usually not covered with slabs. So you are going to create openings in that region. So you are going to also notice that we didn't place slabs in this lift area. This lift your elevator area, this elevator region. We didn't place any slab there because it's meant to be open. It's going to be created as a void. So now let's create a slab opening in this region, assuming there's going to be a staircase here. So to do that, simply um go to your modeling tab. So you are going to see this option that says slab opening or drop. Click on it once. You are going to get the properties dialog as you would expect. So it's as simple as that. So leave the rectangular. There are many ways to insert slab openings, but I want to run us through the most simple way of doing that. So now you are going to draw um um a rectangular selection, just like so. Click on axis intersection point, click on it once, then draw it down. Assuming I want to insert our void here, just draw it down to this axis endpoint again, and automatically we are going to have our void there, our opening, slab opening, just like so. Click close and go to our 3D view. Let's see what you have now successfully created. So you can also notice that we now have our slab opening at this place. Go back to your plan view. So this X symbol, whenever you are reading a structural plan or an architectural plan, there is always an X symbol indicating a void area, which means that that area is a void area. Are you following? So that area, there's no slab in that place. So you can do the same thing here as well if we want, but for now let's leave that just like so. So this is our 3D um representation of what we have just done. So our job is now getting done. Small. We are going to finish this very soon. So the next thing in our agenda is our building setups, um, story settings. So this is basically where we now have to pay very good attention, because this stage of the design is usually very confusing for most people that have used ProtaStructure. So let's pay very attention. So with that out of the way, let's jump straight into that. So now to access your building settings or your story settings, so what you want to do is that we want to create additional floors, maybe two or three floors, additional floors, and then model our members there. So what we are going to do is that we are going to create these floors and then copy all the members that we have now modeled into those floors. We are going to copy our columns, our slabs, slab openings and all that into the next floor. So that is simply what we are going to do right now. So to do that, go to your building setup tab. First of all, we need to create these stories. So to do that, just say insert stories. We have select story, we have insert story, we have this option again to remove story and delete stories, generate stories and edit stories. So let's say insert story. When we have now clicked that, we are going to get this option, this dialog, and then the first option here says story number. This is where you are going to add to specify the number of stories that you want to add. So any number of story that you desire to add, this is where you have the option to do that. So story number, it says 1. Now pay attention. Prota structure recognizes the roof level as a story. Are you following? So if you have a two-story building, it simply means that you have a ground floor, then two additional suspended floors. Then ProtaStructure recognizes the roof level as a story, which simply means that if we want to design for a two-story building, what we simply need to add as our story number is 3, which simply means our two-story level plus our roof level. So the roof level is now recognized as a story in ProtaStructure. So that is how it works. So I want to assume that we are designing for a three-story building for the sake of this class. So that simply means that the number of story I'm now going to insert here is going to be 4, which simply means the 3 stories plus the roof level, which is 4 number of stories. That is how ProtaStructure recognizes that. So to do that, let me simply input 4 here and then say 4. Then in started story heights, let's leave that as default 3,000 millimeters. And here we have add intermediate stories. No, don't check that. Generate member from selected stories. Don't do that now. Just say okay. So when we have done, we have said okay, we are going to get a warning message that is telling us that this and the previous process will be undone after this step. Do you want to continue? What that simply means is that when you do this, you don't have the option to undo that simply by pressing your Ctrl Z. So just say yes and then say okay. So we are going to get this that looks like this. So you have not actually copied any member to the other floors. So you are going to notice as well in your structure tree at the left hand side of your screen, your structure tree, we have your story 0, story 1, story 2, story 3, and then story 4. So all these stories has now been reported here. But you are going to notice that these stories have no columns or shear walls in them, just like this. But in our story 1, we have columns and all that in that because we have modeled that. So now let's now copy this everything that we have now modeled to the other stories above. So to do that, go to your building setup tab at the far top right hand corner of your screen. Click operational story or story operations and then say generate story. I hope you can still see my screen. Thank you.
Yes, yes, we can
Um,
see your screen.
So we have here in the generate story dialog, we have your source story and here we have your target story. So this simply means the source story where you are copying your members from, and the target story are the stories where you want to paste them. So our source story is story 1. So let's say story 1, and then our target story is story 2, 3, and 4. So let's just select that by holding down a shift key and select the story 2, story 3, and then story 4. The member type to be generated. So we are going to generate our column shear walls, braces, and all that. So we didn't model steel members, but let's leave that checked. So slab openings, slab strips, and everything here, and then say okay. So you are going to notice in our background how the yeah, it says process completed. Can you see that now? Then say close. So we have now successfully generated the um, stories to the other floors. So this is what we have now. And you see it's looking very exquisite again. So we have now successfully modeled these 3 stories again. So what you are going to notice that is a little bit unrealistic is the roof level. Knowing that the roof level does not carry this height of wall, and in addition to that, our roof level or the story 4 level does not have slabs. We don't place slabs on roof. So what we are going to do is that we are going to delete all these slabs that are in our roof level. So to do that, simply select the slabs one after the other, just like so, and then say delete. You are going to get this option that um, ask you to confirm the members you are deleting. Just say okay. Now, I'll show you a quick way to do that, just the way we selected all our beams when we wanted to place our wall loads. So to do that, just go to your story 4, open up the folder, and then open up your Slab folder. Select the first one, scroll down to the last one, then hold down on your shift key, select the last one in order to select all the Slab. Now say delete. Confirm that, say okay. So this is what we have now gotten. Go to your 3D view. You are going to notice we don't have the Slab there anymore. So another thing that we need to correct, let's tie this vertically. Go to your views, say tie vertically. So we are going to have something that looks like this, and here we also have this. Yeah. So select one wall load, or select all the beams here. Just select the first beam, scroll down to the last one, and then say shift. Then hold down shift on your keyboard and then select the last one. Then right click and then say, now right click, and you are going to get this option that says delete load. So we want to delete all these wall loads. Don't say delete. Delete is going to clear all your beams. Just say delete loads. Click on that. Select the loads that you want to delete. In this case, I will select the wall loads and then say okay. Now let's now create a new wall load for the um beams that is going to be at the roof level or at the topmost level. So just simply select your beam, right click, and then say edit load, or alternatively you can go to your beam tab and then say edit load. Go to your wall load again, make sure you select your 225 mm wall. It's already there. Now let's change the height of that wall. So in this case, let's just say 600 mm, as the case may be. So let's just say 600 mm. Then click on this beam and then say okay. The same process that we have done before. So this video is going to be recorded. So it's going to be posted on our YouTube. So if you are having any problems or challenges following through, you have the option to go to our YouTube channel and then help yourself with that. You also have the option to slow down the video so that you can be able to follow through very well. So now, having created the wall load in this place, if you observe in our 3D view, this wall load is small. That is exactly what you want. Now select that wall, right click, and then say select the wall and then say right click and then say copy loads. Copy your wall load, say okay. Now go back to your story 4, select all your beams, scroll down, select the last one, shift, and then click there, right click, and then say paste loads. So this is what we now have. So if you have now we have now successfully pasted this wall loads, this small heights of walls in our 3D, in our model, in our um, roof level. So this is what we have. So in order to see this very well, simply go to your views, to your display tab, and then we have the layers option. Click on this axis so that um it will hide our axis so that our axis cannot be hidden. So we now have this model just like that, just like this now. So now go back to that display and layers and then click on that so that you can have our axis back. So that is basically that about all we need to know for now. So now let's go to our story one level and then zoom in. We have now finished our modeling, but when you zoom in now, you are going to notice something very disturbing. What is that? You are going to notice that our beams and our columns are not well are not entirely sequentially labeled. So we have column 1 here, column 2 here. Here is supposed to be column 3, but we have column 26 here, and here is column 28. Our beams and our slabs. The same thing goes for our slabs and all that. They are not very much sequentially labeled. That is why we have the review options. So in our next agenda, what we have here is the review function. This is basically where we ought to um, relabel the slabs one after the other until we finish relabeling them. So what we are going to do is simply go to your menu tab, click on your review tab. So you get this option that says relabel members. So this is where we go in order to relabel our members. So click on that once and then say yes. So we are going to get a dialog where we are going to have the options of inserting the options of choosing how we want our members to be relabeled. So the members that we want to relabel are basically all the members that we have now created: our column, shear walls, beam slab, rib slab. We didn't create any rib slabs, so we can choose to leave that just like so, or we can check that. Let's leave it. So here we have the way we want your members to be sorted. So the columns and slab, we can choose this option that says from left top to right bottom, and we have here the right top to left bottom, all this option. So I will advise you to play with all these things. So when you are now rehearsing or practicing what you have done, you should play with all these things and check out how each and every one of them work. So for our horizontal members, our walls and beams, let's leave the um, relabeling options as from left top to right bottom. Our vertical members, likewise. So we have here this option that says group cantilever slabs separately. So this option allows you to label your cantilever slabs separately after your slabs. So let's check that. Let's leave that as well. So at the top right corner, we have this um, option that says retain compatible labels between stories. Well, if this option is checked, then all the columns are the same insertion point. All your columns, your beams, in fact, all your members that are at the same insertion point will have the same number. We have the same number for all stories. So just check that so that we are going to have that option and then say okay. We also have the option to modify the prefix character. So let's not do that for now. Then say okay. So when we have now done that, you are going to notice that our models and members will now be perfectly and sequentially recorded. So we have column 1 here, you have column 2 here, you have your column 3 here, you have column 4, and in the same sequence, we it goes down to the final column, which is your column 27. The same thing applies for your beams, and the same thing applies for your slabs as well. So the same thing applies for every story in the model. If I go to the story 2, I'm going to get the same thing as well. So that is basically that about our relabeling option. So one other option that we need to check very well is our building model check. So whenever you finish your modeling, the first thing that you need to do before you start running your analysis is going to your building model check. So when you click on that, so this building model check is basically to check for errors or mistakes that you must have encountered when you are modeling your building. So we have mistakes that could be overlapping slab check, your columns placed on top of the other and all that. So just go to your building model check and then say start. When you click on start, it's going to start checking for errors or mistakes that you might have, encountered when you are modeling your building. So this is what we are going to get. Let's wait for it. It's going to complete in about 4 seconds. It will be done. So building model check, it says here building model check completed, number of errors is 0. Then now click close. When you have done that, save. To save, just say Ctrl S to save your project. Now I should have told you about all this in the beginning. So whenever you are modeling, make sure you save your project, because if you don't save your project, your structure, I mean, your software can crash. It can go to a runtime error if you have been modeling for a very long period of time, and everything that you have done before you saved um, is going to be lost. So ensure to always save your work as you are going. Now that is basically that about this building design. So one other thing that I need to explain to you for most people who may not know. So here we have story 1, we have story 2, story 3, story 4. So let's explain these labels here. So we have 1C1. This 1C1 simply is the label of this column. So where we have 1C1 simply means story 1 column 1. So this C1 is simply the number of this column, which says column 1, and the 1 here, which is the prefix before this C1, is just the story number. So if you see 1 column 1, it simply means story 1 colon 1, and here we also have story 1 colon 2, story 1 colon 3, story 1 colon 4, and the rest. So when we go to our activate our story 2, we are going to have the same option. You are now going to notice that we have 2 colon 1, which means story 2 colon 1. We have story 2 colon 2, and it continues, goes on like that. You can drop click on this drop down arrow to see that. So our columns 2 column 1 and all that. So let's activate our story 3. We have our 3 column 1, 3 column 2, 3 column 4, down to 3 column 27 as well. So that's how the labeling works. So we have now successfully finished modeling this modeling and loading building. So in our next class, what we are going to be looking at is analysis, design, interactive design checks, and then we are going to look at the substructure, which is your foundation. So we are going to go through part foundation design, how to design and calculate for that in ProtaStructure. So that last class is going to be very it's going to be very enjoying. I would advise everyone that is here to try to um, go to try to be present in that last class, because we are going to be explaining a lot of things, even things that can only be explained during our advanced class. I'm going to take out my time to make sure that we all understand that. So you can also notice additionally how I was going very, very slow, one after the other, doing creating the beams, creating the slabs one after the other. The reason is because whenever you are doing a structural design, you must be very, very meticulous. You must be very, very clever, careful, because when you make any mistake, it can result to a very huge catastrophe. So take out your time, model your buildings, and perform your structural design very, very carefully, so that um, you don't have to make any mistakes, so to avoid any failure or collapse. So this is basically what you have now successfully achieved in this class. So press Ctrl S to save that. Now for your assignments, do a complete modeling of your design work. So that 3D that DXF that I have sent, that I dropped in the group, you ought to go back there and import that. Your assignments, you have to complete that. So let me close this project so that I can begin with that. So in your assignments, this is basically where you stopped. Let me open up this project. So this is basically where you stopped um in your assignments. So you are going to complete that, do the same exact thing that I have now done, the same exact thing that I have now done. Let's open a plan view. So this is what your assignment should look like right now. This is where you actually stopped. So go to the plan view now. You are now going to start creating your beams. After modeling your beams, model your walls first. You are going to use 300 millimeter width of wall. Just use 300 millimeter as the B for your wall in this region here. So create your walls here. Now start modeling your beam. Go to your building modeling tab, click on the beam tool, place that, and now start placing them one after the other at regions where you have these beams. So use this external reference drawing as a reference to guide you to know where you are going to place beams. So remember that I said that you must create the supporting beams first, or your supporting members first, before modeling any beam. So for instance, we are going to have a beam here. Press escape, and we are going to have a beam here. So always make sure that you have modeled this particular beam here before you are now modeling this beam. Are you following? So don't model this beam here before modeling this one here. As you can see, when you do that, you are going to be getting this cantilever marking. So that is a very wrong way of doing your modeling. So you should know it's going to split this beam, which is going to make it a very awful modeling, a very um bad modeling. So say Ctrl S to undo that, Ctrl Z rather. So that is what you're going to do. So now model all the beams, go to your walls, model your walls, observe where the axes are, model your walls just like so. Have your walls here and create your beams in this region. You have the option to use any beam depth and your beam width that is desired, but I would advise you to use a beam width of 225 millimeters. Then you have the option to use beam width of 450 millimeters. So let's delete all these beams here. So insert your slab here. So you might find yourself having issues in this region. So this is just the exam same process that we have went. So when you now want to insert your slab here, when you have now finally successfully inserted your slab here, so now use your slab opening option to now create a slab opening in this place. Just go to your modeling tab, slab opening, click on this place, drag it down to this place, and then you are going to have your slab opening. So I'm just telling you all this because I know these are areas where you might have problems in your assignment. So insert a slab here and then create a slab opening. The same thing applies to, okay, that is that. So the same thing applies here as well. You are going to create a cantilever slab in this region. So to do that, go to your slab icon, select your slab type 12. Now enter your length of cantilever. Let's say length of that cantilever. Okay, first of all, measure that. To measure in ProtaStructure, right click and you're going to find that measure option here. Alternatively, you can press Ctrl R. So now measure the distance from this place to this place, and that distance is 166.3 millimeter, 1663 millimeter. So that is going to be the length of your cantilever slab. So go back and click on your slab option again, loads, general first, slab type 12. Make sure you set the slab depth, concrete cover, the required loading. So what you are going to be using as your imposed load is your general domestic use. That's for your residential building. Then input your length of cantilever, which is 1663 millimeters, and then go back to your general. Now input, click on this point, click on that point, and then click outside. So you are going to get this what is it called again, this your cantilever slab, this region. So you are going to have the option to create all of your slabs. So That is basically that about your assignment. So does anyone have any questions so that we can attend to that before we finish our call? All right. Thank you very much, everyone. God bless you.